This video provides an overview of the various troubleshooting and maintenance processes that you can consider to ensure the functionality and reliability of the connected and automated vehicle devices from the perspective of Cave-in-a-Box. Effective device troubleshooting inside the vehicle and on the roads is as critical as proper configuration to ensuring the success of the intelligent transportation system. Now, we will discuss maintenance activities for the Cave-in-a-Box infrastructure and vehicular kits. For common device issues, we will offer a single solution for both kits, and in instances where troubleshooting steps differ between kits, we will provide individual solutions. If a particular device in either kit appears to be malfunctioning, the first step is to power cycle this device. For best practices regarding power cycling Cave-in-a-Box components safely and effectively, please refer to the Appendix A of the System Design document, which is linked below. The second most common issue relates to loss of network connectivity. The Cave-in-a-Box system is designed to have all of the equipment connected to the same private network to make configuration easier. For best practices regarding verifying network connectivity with Cave-in-a-Box, please refer to the Appendix A of the System Design document. Once the physical power and network setup have been verified, a ping command may be used to test the connectivity of the equipment. This may be achieved by connecting to the network using a laptop and typing the ping command, for example, ping 192.168.55.68 in the terminal or command prompt window on Linux or Microsoft Windows-based devices, respectively. If the devices return a ping, a successful connection may be determined by observing the following response. This response will also include the time required to return the ping, which may be critical while troubleshooting latency issues within the system. The next step would be to troubleshoot the VitaX subcomputer. Please check out our earlier videos to learn about the VitaX subcomputer. Once logged in, use the sudo docker ps command and observe the output, which should show the three containers, MySQL, Apache PHP, and VitaXHub as up and running. If any of the containers seem to have stopped running, then you will have to navigate to the correct configuration folder in the VitaXHub directory. cd VitaXHub configuration ARM64 and run the sudo.initialization.sh command. This should restart all the containers and provide access to the VitaXHub GUI and admin portal through the browser. The Cave-in-a-Box configuration video and other VitaXHub materials are available online. The traffic signal controller in its current implementation sends the SPAT messages to the VitaXHub computer. The receipt of the SPAT messages on the VitaXHub computer may be verified using the tcpdump port 6053 command. The port number may be changed to that configured in the VitaXHub SPAT plugin. The configuration interface on the controller may also be used to set the controller to factory default. Other traffic signal controller-based applications may require more specific troubleshooting and further instructions from the manufacturer. The output from the VitaXHub is also sent to the RSU. This may be observed by checking the messages being sent to the immediate forward port on the roadside unit or RSU using the tcpdump port 1516 command in a terminal for the VitaXHub computer. Once the messages are confirmed to be received on the RSU, then the final step would be to verify that the messages are being broadcast out over the available wireless interface. This may be done by using the corresponding vendor-specific tcpdump/icwmon-txb command. The vehicular kit, which is the vehicle onboard component of Cave-in-a-Box, is powered using the vehicle's auxiliary power, which is rated at 12 volts. An inverter then converts this to 120-volt AC, which may be used to power the various components using standard AC receptacles. In certain cases, onboard units or OBUs have the option to be connected to vehicle power and ignition. The lights on the OBU indicate the power and functional status of the device. Various lights on the router and the inverter itself may be used for the understanding of power delivery to the various components. If components are not receiving power, you will need to verify vehicle ignition and power to the 12-volt auxiliary port. Check the manufacturer's instructions to verify that the lights indicate complete functionality. In certain cases, a good GPS lock may be necessary to ensure complete functionality for the OBU, and the appropriate lights on the device may obtain the confirmation. The two pieces of network equipment included in the vehicular kit are the network switch and the Wi-Fi router, which may be confirmed by checking the link lights on the Ethernet ports. The same troubleshooting steps as for the infrastructure kit may be carried out to ensure network connectivity. Once the physical power and network setup have been verified, follow the steps to ping devices outlined earlier in the video. The next step should be to troubleshoot the onboard unit. This may be observed by checking any messages being sent and received from the onboard unit through the wireless interface using the tcpdump I wireless interface name command in a terminal after logging into the OBU using SSH. When mounting an OBU, the ideal location within a vehicle would provide easy access to the device mounting and the different connectors on the device. This allows for easy troubleshooting or interchangeability of the device and its components. If performing a non-permanent installation or an installation on a cloth surface for testing or prototyping, the use of a hook and loop fastener is very useful and will hold the device securely. Otherwise, for a more permanent solution, mechanical fastening to the vehicle or structure mounting in the vehicle is preferred. The antenna for the OBU is mounted on top of the vehicle with the cabling run ideally through the trunk opening. If multiple antennas are present on top of the vehicle, the antennas should be no closer than 10 inches apart. Cable routing is dependent upon the vehicle in which the device is being mounted. Commonly, the antenna cables are run down the roof line of the vehicle. On a coupe-style car, the cables can be run down the rear glass edge following the contour of the C-pillar. The best placement is generally along the deck lid top, where there is an ample flat surface to be able to fan the cables out along the weather stripping. On a hatchback-style vehicle, the cabling again can be run along the roof line and then fanned out along the upper 90 degrees of the door opening, the top two corners. Be sure to test the closing of any deck lid to check for cable kinks before performing a final close. A dependable way to secure the cabling is to use zip tie squares with an adhesive backing. They can be attached to windows of vehicles without the potential risk of damaging vehicle paint. It's necessary to test connectivity and resource availability in a cave-in-a-box to enable backhauling of data over to remote servers and TMCs. The cave-in-a-box should support IP networking, pinging to the remote server. Therefore, the cave-in-a-box should equip one interface for the virtual private network for data security and one for the internet. If cave-in-a-box is not able to ping one or more of the TMCs or remote servers, the first thing to check is the IP routing table, domain name server, firewall rules, and gateway information. If one cave-in-a-box is handling multiple intersections, then one of the checks is to make sure that the configurations on VitaXHub are associated with each intersection. The immediate forward plugin can forward SPAT and map to distinct intersections as required. In addition to this, a simple ping test to each connected intersection should be done to ensure connectivity is reliable. As mandated by the Federal Communications Commission, prerequisite to any testing in the 5.9 GHz frequency band requires obtaining a license. The steps include creating an FCC registration number to access the online application process, applying for a non-exclusive geographic area license based on the test site of interest. Finally, each device being used for testing should be registered with the FCC. This includes make, model, mounting latitude, longitude, altitude, and height, channels for being used for testing, and other information as needed. In this video, you have received an overview of common troubleshooting and maintenance processes for components in the cave-in-a-box infrastructure and mobile kits. Pairing these steps with detailed specifications in the Appendix A of the system design document and setup and configuration processes from the previous videos in the series, you are ready to operate and maintain cave-in-a-box on your ITS system. If you need additional help, please feel free to reach out to CAV Support Services at dot.gov and reference our maintenance manual.